Hello and welcome. My name is Vishwanathan. In this video, let us try to learn and understand a very useful and an interesting concept called hashing. If you are following the VTU syllabus, this is program number 12 of the Data Structures Laboratory. Hashing is a technique that involves storing large amounts of data in much more efficient and secure ways. So in any hashing methodology, these are the common terms that you would encounter: keys, hash function, and storage, or this would be replaced by hash table in most cases. So a basic understanding of hashing or hashing methodology goes like this: keys or the data is converted to much more efficient and secure at times as well fashion of data or format of data using the hash function. So hash function in this case, in this image, is unknown, so it is just lambda, and as you can see, the data or the keys that are coming in are converted to a format of a different type and stored in the hash table in an efficient manner. So that's the basic understanding of hashing. With this background, let us jump to the program where we are implementing hashing using a very simple mod logic methodology. So any C program would include the header files stdio and stdlib.h. In this case, why we are using stdlib is because we are using a function called malloc, which is a dynamic memory allocation function, and that function is available in the header file stdlib.h. We are creating a set of global variables, int employee key, which is an integer type array of 20 elements, and we are naming it employee key, and other variables are hash index. We already know what the hash index is. N and M, we will understand what they are when they are used in the program. Star ht is a pointer that we are creating, so integer type pointer. So pointers in C language basically are variables that refer to the location or address of other variables. And ele count, as you would guess or as you would think it would mean, ele count means element count or the number of elements in the hash table. We will understand later in the program, and we are initializing it to 0. So before we jump into the functions, we have three functions and of course the main function. Let us spend a very brief amount of time understanding the applications of hashing. So hashing, we have already understood that it stores data efficiently. So one very popular application of hashing is it could be used in deduplication and compression. Hashing is also used in some encryption technologies or many methodologies in cryptography, where key, even in this case you would see that key which is like this is passed to a hashing function and stored in a much more secure way because we are encrypting the data. So hashing primarily is useful in efficient storage of data, maintaining data integrity, and even at times used for encryption. And there are a lot of other applications of hashing which makes our learning really useful. So before we understand the three functions, create hash table, insert into hash table, and display, we will first understand and see what main function does in the program. Any C program will start execution from main function, and inside the main function we are creating a temporary or iterary variable called I, and then it is just a set of messages that we display in the output screen so that we get the inputs. So printf enter number of records. So in this program we are dealing with an employee database, and how do we ask the user the number of records? By this printf statement, and we accept the input and we store it in the variable called n. So n is a global variable. So the advantage of creating variables outside all the functions, or in other words global variables, the advantage is that these functions are accessible to all the functions in the program, and hence there is no need to pass the functions as parameters in the function calls. So the scope of these variables are at the global level, and hence they are called global variables. Alright, So we have accepted the first input, that is number of records, that means number of entries in the database, and then we next ask the message to enter the hash table size. So let the hash table size in this case be m, or it is stored in the variable called m, and then once we know the number of records, we want the user to enter those records. So how do we do that? We display the message, enter employee key values or EMP key values, and we run a for loop for n number of times. So this makes sense because the number of records is 5, so the number of records is n, and we run the for loop for n number of times. And in every iteration of the for loop, we are accepting the input and storing it in the array called employee key, and EMP key is an array that we have defined at the global scope here. So once we have accepted all the values or the key values or the records, you could call them, we call the function create hash table. So create hash table, when control sees this line of code, the set of lines in create hash table function, which is defined here, is executed. So we will understand these functions later on, but let us finish the main function to get a brief understanding of what is happening in the program. So after we have accepted the input for the employee key values, we are creating the hash table by calling this function. Once the hash table is created, or you could imagine a hash table like this, and it would be an empty hash table because we are yet to insert keys into the hash table. So after the hash table is created, we print a message saying inserting keys into the hash table, and we run the for loop for n number of times. So it is n here because the number of key values is n. So for I is equals to 0, I smaller than n, and I plus plus, every time we first check a preliminary condition. So LE count indicates the number of elements already present in the hash table. So if the element count is equals to m, in other words, if the element count is the maximum number of entries possible in the hash table, obvious message would be hash table full, and we will print the message that can't insert the next key. So whenever whenever we are inserting a key, if the hash table is full, we will just print a message that that particular key, and of course the rest of the keys as well, cannot be inserted into the hash table, and we simply break out of the for loop. But if this condition is not satisfied, which won't happen unless the hash table is smaller than the actual number of records, so this condition wouldn't execute or wouldn't satisfy, and hence this function will be called insert into hash table. And every time we call the function insert into hash table, we are passing each variable or each element in the employee key array. So every time the insert into hash table is called, the set of lines under the insert into hash table is executed, and every time the employee key element is passed, and that would be processed here as key. We will understand insert into hash table function later on. So for loop runs for n number of times, that is number of times equal to the number of key values that the user has entered, and once all the keys are entered into the hash table, we display the hash table. So that happens in this function, and once the display function is executed and it returns to the main function, we have completed the execution of the main function, or in other words the program itself. So let us now understand the other functions in the program. Void create hash table. So as one would understand, this function is used to create a hash table. How do we create a hash table? We first have to allocate the space or memory required for the hash table. How do we do that? We use the function called malloc. So malloc stands for memory allocation, and malloc is a dynamic memory allocation function that is used when the size of the hash table, or when the size of the table, or when the size of the allocation is known beforehand. So in this case, we are asking the hash table size beforehand and storing it in the variable called m. So using malloc function makes perfect sense. There are other functions under the dynamic memory allocation set of functions called calloc and realloc, which should be used in other instances. So malloc is used when the size of the allocation is known beforehand. And how do we calculate the size? M is the hash table size, or the number of entries in the hash table, and we are calling the function called size of int. So integer we know is 4 bytes in most cases, but it could be different depending on the architecture of the system that you are using. So safer side, we call the function size of int, and we multiply with m so that we get the total space required for the hash table, And always remember that malloc function returns a void type pointer, and but we in this case need a integer type pointer or integer type pointer, so we are typecasting it. So what this integer star in parenthesis does is it typecasts the return value of malloc function. So whatever was the return value of malloc is a void type pointer, but since we are typecasting it to int, ht will ultimately have a integer type pointer or pointer of type integer if ht is null. So when does ht be null? Ht, as we know, is a pointer, or a pointer basically refers to the address in the address or location in the memory. So when does ht become null? So assuming a very rare scenario where we are creating a table which is too huge in size, or let's another possibility is the computer is running a lot of applications. In that case, there might not be enough memory or enough space to create a table or create a space of the given size. In that case, ht will have null, or in other words, it cannot really point to a set of addresses. So it will just have the value null, and in that case we will print memory unavailable. So this is a very rare scenario which will normally don't happen unless the size of the table is too huge to be created in the memory. So if this condition doesn't execute, this is the normal set of lines that will normally execute for all our programs. Else, for int I is equals to 0, I smaller than m, I plus plus. So we run the for loop for m number of times. M, we know what it means is the size of the hash table. So m is the size of the hash table. So when we are creating a hash table, we are initializing, or we are creating a table with the default value as -1. So in this case, you would see a blank space in the image, but for our laboratory purpose, we are creating a hash table with default value as -1. So empty hash table will have all the values as -1 in the hash table. So that is happening in the create hash table function. Next function is void insert into hash table. Insert into hash table, as it sounds, so it means. So what are we inserting into the hash table? We are inserting the key. The key is coming from the main function. The insert into hash table is called passing the element from the employee key array, and that is processed here as key parameter. So we are inserting the key into the hash table. How do we calculate the hash index? So hash index basically refers to this index. So how do we calculate that? This is a very common method of creating hash indexes using the modulus operator. So whatever is the key, we use the modulus operator. Modulus operator basically returns the remainder of the division. So if let's assume the key was 11 and m was 5, 11 mod 5 is the remainder of 11 divided by 5. 11 divided by 5 is, the quotient is 2 because 2 times is 10. The remainder is 1. So 1 will be the hash index value. So this is a very common method of creating hash indexes. There are other ways as well, but this is a very simple and commonly used method to create hash index. So in the program, we are also asked to use a technique called linear probing. So linear probing comes into play only when the particular hash index is not empty. So in other words, when we create the hash table, it will have -1 as the default value. But if the hash index is already having a value in that, it will not have a value of -1. So in that case, linear probing, what it does is it will slightly modify the hash index by incrementing hash index by 1 and using the same logic again. Hence the name linear probing. Hash index, whatever was calculated before, will be incremented by 1, or an addition of 1 is done, and we use the same modulus m operator here again. So the new updated value of hash index will be used for hashing in that particular case when the hash index is already having a value in it. But if this is not the case, it is very simple. Whatever was the hash index created at this line of code will be straightforward used. ht of hash index is equals to key. So key will be stored in the hash table at the given hash index, and every time a insertion operation is successful, we obviously want the element count or ele count to be incremented. So which was 0 in the beginning, it will be incremented every time the insert into hash table function is successfully executed. And after we have created and inserted data or keys into the hash table, the only other function left is to display the hash table. How do we display hash table? We create a temporary or a iterary variable called I, and we do a basic preliminary check. If the table is empty, that is if the element count is 0, we know that count is tracking the number of elements in the hash table. If it is 0, we print the message hash table empty, which makes perfect sense. If that is not the case, if the hash table is not empty, we run the for loop for m number of times. Why m? Because the size of the hash table is m. So we run the for loop for m number of times, and we print that t basically refers to the table. So table of index is storing this particular value. So we will t of percentage d, the percentage d will be replaced by I, which is each index in the hash table, and percentage d refers to the value in the hash table itself. So if you are for easier understanding, 0 1 would be I, that is t of 0 1, and this arrow mark will be printed as it is, and the next percentage d will be replaced by ht of I, that is hash table of I. Hash table is this, I is 0 1 in this case, hash table of 0 1 is this value stored in this particular index. So that is how the output will be printed. Again, here is the image used is a different hash function, because it's converting, it is accepting strings as input, but in our case it is an integer type input. So again, the understanding is pretty much the same, but you wouldn't see the exact same strings getting converted to integers and storing in a hash table, but it will be integers storing in integers as well. So that is how the input, that is how the display function executes or displays the hash table. So by this we have completed the program, that is understood all the header files and the global parameters, and understood all the three functions, and of course how we have understood how the main function will execute in this program. So let us now jump into the execution and see how hashing is actually implemented in this program. How do we execute C programs? By using the GCC compiler or global compiler. The name of the file is p12, and it is a .c file. Small c basically refers to a C programming file. So if there are no errors in the program, we would have no error messages, and we will just have a blinking cursor waiting for the next input. But normally there will be some errors. For example, let's see how an error would be displayed. We have missed a semicolon at this line, so let us try to compile the program again, and there we go, we see an error message. Very important thing to do when we see an error message is not to panic, but read the error message and do the required debugging as required. So in this case, it clearly says it was expecting a semicolon before the closing braces token, and where is that closing brace? It is in line number 25, and before that it was expecting a semicolon. Line number 25 is here, and before that it was expecting a semicolon. And once we have entered the semicolon and save the program again, we will run the program again to see if there are any more errors. We will run the program again to see if there are any more errors. This was a typo, so make sure that you are not entering any other symbols. So gcc p12.c, there we go, there are no errors in the program, because that was the only error we made intentionally. So once we have successfully compiled the program, we will now execute the program by entering the code or command like this, /a.out. This is how you would execute any C program, so you would already know this. Once we have entered the execution, I already said that main function is where the execution starts, and this is the first line in the main function, enter number of records. So let us have, for simplistic purposes, let's say 5 records, and let us create a big enough hash table. Let's create a table of size, let's say 10, and let us now enter the employee key values. So for again simplistic purposes, let's just consider values like 1001, 1002, 1003, 1004, and 1005. So these are 5 employee key values that we have entered. So once we click enter at this moment, basically it will create the hash table. That means the line of code under create hash table function will be executed, and after that a message called print inserting keys into the hash table will be displayed, and the for loop will run for n number of times, that is 5 in this case, and each key that we have entered will be inserted into the hash table. Once all the insertion is done, we will display the hash table. So we just have to click and enter now and see the magic. There we go. So we had 5 keys starting from 1001 to 1005, and we had created a hash table of 10, we know that the initial or the default value we had chosen was -1. That is why you would see the table having -1 as a default value, and hashing has occurred, or hashing has been implemented at the background. So each key is having a hashing index, and therefore this data that we have entered has been stored in these particular indexes. Again, so the data that you would enter will decide where the hash index will be created. So for demonstration purposes, let's do another iteration. Let's use the same number of records and same number of same hash table size, but enter a different set of inputs. So let's say use 1 2 3 4, 1 2 3 5, 1 2 3 7, 1 2 3 9, and 1 2 3 0. So these are the 5 records that I have entered, and let me just click enter now. So let us appreciate the output here. So the 5 key values that we have entered has taken different positions in the hash table depending on the hashing function that has been executed or implemented at the background. So other indexes or other values in the hash table are empty, and that is indicated by -1. So we have understood very effectively what hashing means, the theory of hashing. We have understood the program which implements hashing in a very simple fashion, and we have also understood how hashing is implemented in a Linux environment. This was all in the video. Thank you.